today have the pleasure to introduce our keynote speaker, James Black. James is a Senior Director for Insights Engineering at Roche, but he's also all over the open source space. So he is a founding member in the Open Source in Pharma, which is the nonprofit that actually takes care of R in Pharma. He's also involved in the Pharma Government Council of the R Consortium and many other initiatives, including the Pharmaverse that was just discussed right now. James' talk is the importance of the SCE enabling our shift from proprietary programming to open source data sciences. James, the floor is yours.
Cool, thanks very much, Paolo. So yeah, as you mentioned, my name is James. I'm an SCE product owner for late stage at Roche. And I realize I'm one of the many SCE product owners across our industry. You know, assuming if there's 2,000 pharma and biotech companies, there's 2,000 of us product owners. So in the next 30 minutes, you'll hear in detail my perspective. But later today, there's also going to be a panel of SCE product owners. So it'll be a chance to hear from a broader group there as well. So the thoughts I share are influenced by discussions within our pharma and places like Fuse, but they're very rooted in our experience at Roche. So I'll start by sharing a little about the context I'm coming from. And this dramatic shift in what an SCE actually is started at Roche about 8 years ago. So I'll talk about our initial experiences there in real-world evidence and then moving into personalized healthcare. And then I think one of the most fundamental problems we need to discuss right now is what an SCE actually is. So I'll move on to what is an SCE and then close this out because many companies are right now going through a change, adapting to the changes happening in clinical reporting. As Sophie introduced, the Pharmaverse is coming. And we need to get to a position where these SCEs can catalyze this revolution rather than stifle it. So I joined Roche from grad school in 2015, and that was right about the time real-world evidence split from biometrics, and they created this new informatics organization as well to support this new department. So this meant we were building our own SCE. I also, over the next 3 years, moved from a contributor into management, so then started to think a lot about how we can help the team deliver impact efficiently. And around 2018, we had a department shuffle occur where the personalized healthcare team were merged with the real-world evidence team, which meant suddenly we had imaging and omics, so new data modalities going well beyond the kind of tabular data we knew in real-world evidence. Were suddenly part of our SCE landscape. And then just a couple of years ago, I shifted from a team that did science to a team that enables science. So I'm now in a group called Data Science Acceleration, which is about 40 people focused on data science tooling and workflows and compute environments and data pipelines and things like that. And then in 2023, so this is relatively recently, we launched our new clinical data reporting platform. And so this included a new SCE, as well as an overhaul of how data is done in a fully cloud-based system. So in terms of my current role, I'm very close to the R tooling. So I sponsor our Insights code base. The most well-known piece of this being Nest, which is a pivotal part of our clinical reporting strategy. I'm also the business lead, working closely with informatics for the compute we use in late stage. And that's for both the real-world data and advanced analytics side, which we do on a platform called Apollo, as well as the clinical trial reporting, which we do on a platform called Ocean. And as Paolo mentioned, I'm involved in some external efforts like the Fuse SCE Council. And just recently, Satish and I from Johnson & Johnson chaired the SCE discussions that happened in person in Chicago. So the opinions here are my own, but they're very much influenced by Roche and to a certain degree, these external discussions that are happening. So I touched that I'm very much in the late stage, which is development within the drug development pipeline. And so just to kind of scope what I mean by an SCE here and the focus of the SCE, I'm talking about something that enables this development stage. So we have, discovery, we have early development, and then it moves into humans, and we start talking about development. And then after development, we have access and commercial. And there's no hard lines here. It's not like there's this kind of hard shift where it moves from SCE to SCE. There is overlap, but I'm specifically focusing on something which enables development. So in terms of our kind of historical experiences, when I joined Roche in 2015, the clinical trial data was all trapped in the SAS-only kind of kitchen sink platform. There was a way to get data out of it, but it was a one-way export. So you could kind of pull data out, but then the original platform would have no idea what happened to that data after that. We also had an R server, but it was one where it was managed by IT. I think it was every 6 months they updated it. So there was quite a long time between updates occurring on the system. And what was most painful coming in working on real-world evidence was all of our real-world data was in a network drive. So that's both the raw source data, so for instance, terabytes of claims data, as well as the derived data that we created. So this meant reading data took forever, like 6 or 12 or even longer hours was not unheard of. And we also were duplicating data like crazy because everything took so long. We would save copies of each step. And so there were a lot of kind of convenience copies flying around, which obviously would make our data stewards feel a bit uncomfortable. It was also a pain having to make tickets. If you wanted any small edit to your system, even if you were just prototyping and you weren't that worried about things like qualification and validation, we would still need a ticket to do anything. And there was kind of this like unwritten stance that actually the laptops were the best place to work in our department. Then there was kind of a dramatic change over the next 3 years. So from 2015 to 2018, we changed how real-world evidence was generated, as well as the infrastructure that people were working on, so the SCE. So from the infrastructure side, we got rid of the network drives and moved the data, both the source and the derived data, to mostly Redshift, but a little bit of S3. And then we also moved from informatics managed servers, so like show up and work servers, like put a URL in, suddenly you're in our studio. And we took that away and replaced it with a container launcher. We also had an internal CRAN server, which later got replaced by Posit Package Manager, so that users would now control more of the packages available. And we also had Connect, so there was a lot more applications being generated. So on the business side, we saw this kind of dramatic shift in the tools data science we're using as well. So it's pretty much all the work initially moved to R. There is a little bit of Python now. I think we have one person in the real-world data space who's 100% Python. But there was a big shift in what language they were using. A little bit of this was policy-based. So there was kind of a conscious decision, as we've seen with the Fumaverse, that any pan study tools, would be written in R, so that there was a common language. But it was also just an expectation of what people wanted to do and what they wanted to produce. So when people saw HTML outputs, it pretty much got rid of the Excel outputs very quickly. And then also when stakeholders saw Shiny apps, it was very quickly a move, well, actually, I need to know how to make Shiny. And if I'm writing Shiny apps, I'm probably switching my analyses to R as well. And so as we rolled out this new SCE for real-world evidence, it did go hand in hand with this dramatic shift in the way we expected users to work. And this was kind of a symbiotic relationship where, we would do something like say, hey, for version control, we want to switch to Git. And obviously this has big change management implications, but it also just changes the skills that your data scientists have. So when we switch to Git, now they're familiar with GitHub and GitLab, and they're starting to think about what Git flows work for different use cases. When we brought in SnakeMake, so SnakeMake's a Python library. It's a bit like Targets, but it's Python-based and language agnostic. And it meant that suddenly users would have to have an understanding of code-based workflow tooling. We had this concept of reproducible research, which was when you did a production run directly off the Git repo. So there was a little bit of familiarity with CI/CD needed, because our very first version used Drone, which is a CI/CD tool. But I guess one of the most important pieces there was really stressing that mindset of if you ran it interactively, don't trust it. Like it needs to be a production batch run for it to be something that you can share with stakeholders. And the shift to Redshift and S3, you're moving away from Unix permissions. So people are needing to understand secrets. They may be dealing with secrets managers. They're needing to work with APIs and like, for instance, ODBC onto different databases. And I think shifting from using like a vendor language where you're given specific tools to use to R, where there are so many tools and so many overlapping tools, and there's so much collaboration going on and people pushing their own solutions up, meant that there was kind of a shift in people thinking through things like, what dependencies am I actually going to use in this analysis? And then one which I guess helped the more advanced users was that switch from managed servers to containers. So you could keep using our managed containers, which were kind of a ready-to-go environment, but users could also extend them. So they could add in some system libraries and take ownership of the environment. So I've kind of got quite far into this talk without actually talking about what an SCE is. And I actually haven't mentioned, I think so far, what the acronym stands for. So in the clinical reporting context, usually we're talking about a statistical computing environment. At Roche, we decided to kind of rebrand it a bit as a scientific computing environment, just to align with the fact that our stakeholders go from statisticians right through to imaging scientists. And so a few years ago, Fuse created a white paper, which is a great read. And it has a lot of details that I'm skipping over today on like what are the actual components of an SCE. And it's coming from the position of an SCE for clinical reporting. But there's a quote I quite like from it, which kind of gives a high-level aim, which is that a modern SCE must allow for functional, meaningful, and delightful experiences to end users, which I think is a pretty good goal when we're rolling out our next generation of SCEs. So kind of if we take the Fuse white paper, it's grounded in taking CDISC data, or creating, firstly, I guess, the SCTMs, and then taking the CDISC data and ending up with submission data and TLGs for a GXP use case. I think there's a question there around, well, what about exploratory work? I've heard across different companies that's approached differently. And in a decent number of companies, the SCE that does the GXP work is not the SCE that does the exploratory work. And I think that's something which we have kind of gone away from at Roche with our current generation. And then if we kind of keep peeling back the layers and going further and further away from the CDISC work, what about like trial design? Like the statisticians designing the trials, is this works? Would it be ideally happening in the same SCE? And then we move to things like real-world evidence, or within trials, historically, an omics domain might have been reduced to a binary variable before it appears to the clinical trial team. But now we may get access, for instance, to the raw NGS test with 200 alterations and a profile of a tumor. And if that data is now available close to the clinical trial data, does this now mean that we're supporting bioinformatics? And the same with imaging and digital biomarkers. Like how wide is the scope of an SCE in late stage now? And kind of going to the extreme of that, we have concepts like MLOps, like do we need model repositories in an SCE? And for software as a medical device, like is that sort of activity going to be happening in our SCE? And I think one of the big questions we have today is like historically, especially with the vendor products, data and compute kind of came as one package. And when we're starting to build kind of the next generation of SCEs, that's a concept that's, I think, definitely been challenged. And if you think of like an HPC, in an HPC, you might have a scratch space, for quick reads and writes as part of your analysis, but you're not the source of truth for the data. And I think that's kind of a direction we're heading in now with the current generation we're rolling out, which is decoupling data from the SCE. And so to put this in the context of a real SCE, I can share a little bit about our late stage platform we have at Roche. So we have Ocean, which is kind of, if you think of Ocean and Apollo, it's almost two different profiles. So for people doing clinical reporting, they open their web browser and they can access a platform. If people are doing personalized healthcare or real-world evidence, they can open a browser on a different domain and they get the platform for them to work in. But the core SCE is shared between these two environments. So for instance, the container launcher, POSIT package manager, the Connect server, the managed Docker files, all of these things are common between these two platforms. What's just different is kind of the context that they're working in. And I guess on top of that, the actual study management is very different between clinical reporting and real world evidence, or PHC. So those two are much more disconnected. But the point I was stressing on the last slide is that we push as hard as we can to keep the data as decoupled as possible from the compute. So that's relatively easy to do with real world data, where we're dealing with ODBC or S3 API connections to data. It's a little bit more of a journey with clinical trial data, which has been so ingrained to have Unix permissions for the last decades. But it's what we're pushing towards, to essentially cut that hard link between the data and the compute. So there are some limitations here. So for instance, if we build our compute on AWS and we have Frankfurt in Oregon, we then don't want to go put the trial data on GCP in a completely different country. We want to co-locate to save money and to increase performance, but we don't want to tie the infrastructure code together. And of course, there's also other data sources we use outside of the domains that we control, like clinical trial and real world data, like, for instance, the source of truth for the imaging data or standards and stuff like that. And I'm guessing this is probably something that's going to pop up and may already be in the questions. But one pain point with these new SCEs is always going to be validation. And validation can very quickly kill the ability to build an SCE that can kind of rapidly iterate as the landscape changes. So one thing we've pushed for very hard within the development of our new SCE is to isolate out what actually really does have to be validated, and not to try and validate the entire system and kind of trap those use cases where validation isn't relevant, like exploratory. So to kind of give a very simplified example of what this means in practice, if you are working in a container and you're typing, so you're in RStudio, you're in VS Code, you're typing stuff and running code, generating outputs, this stuff probably hasn't been QC'd at all, like it's only been seen by you. You're not sharing it, to a study team yet. This is all work which is not relevant to the validation. When we talk about validation, we're talking about a batch run. So the process has been gone off and picked up your particular repository. It's picked up a version of data. It's picked up which Docker file or ECR image you're using, and it's run the analysis without the risk of a human kind of contaminating it by running things out of order or not having code committed and stuff like that. And I guess one really important piece is also capturing the metadata. So all that information about how the insight was generated is being captured at the same time. And I think just being able to isolate out like just this process, just this batch run as being the thing that needs to be validated can simplify the process of getting your platform into production dramatically. So I've talked about real world evidence and kind of some of the general concepts that we're trying to push in what is now the SCE we have in production. So from the real world evidence, some of the real world data experience, it sounds like it's a really easy transition to bring this kind of data science platform in. But when we did this with real world data, we had about 40 people in the team, and it was an emerging field. If we look at kind of clinical reporting, at Roche, we have 800 statistical programmers. On top of that, we have all the statisticians. We have 20 years of tools and a huge amount of experience in the way things are done today. And it's been much more iterative, the changes over the last kind of 10, 20 years. So we're talking about quite a dramatic shift happening rapidly. So, I mean, what you can take from my talk so far is that it's very easy to build a brand new, like all the bells and whistles, data science, scientific computing environment, as long as you get to start from a completely blank slate. That is like absolutely not true when we're talking about business continuity in clinical reporting. So we do need to kind of balance this and find a way to make a transition to a modern SCE that catalyzes kind of further innovation as well, and embraces a lot of the ideas coming out that we're adopting from data science, but we still need to maintain the ability, to get our drugs approved with health authorities. So I think one of the most important steps in this transition is being super clear on what the expectations are around change management relative to your legacy SCE. So this is kind of just me bucketing terms I've heard mentioned quite a lot. So you can kind of take it or leave it, the phrases I've used to bucket. But essentially there's the kind of, we'll keep existing processes and they'll be supported as is. So this is like the teams will still be super efficient working the way they used to do in this new SCE. We did dabble with this idea for a short while at Roche. It's definitely the hardest to implement, especially if your prior SCE was a vendor tool. And it kind of leads to a lot of concessions on how you can work and have that work the way you want to work, be compatible with the way you used to work. So I guess for anyone on this path today, I know life is not great right now, so I'll just kind of leave it there with a picture of a puppy. But I think a lot of companies are focused on these last two. So for a multilingual future, I think what we're really saying there is about what happens to the legacy skill sets and the proprietary languages rather than the adoption of the new open source software. So it's kind of a statement like, hey, to our users, this platform will be able to support legacy and it will support it in an efficient way. Like we're foreseeing a future where legacy lives alongside this new open source revolution. And I think the third stance that you hear a few companies talking about is a much more aggressive open source within our backbone. And in these, you're saying, well, actually, it's still a multilingual future, but we're specifically saying we're really pushing that it's going to be R with backbone, with just the open source tools, and kind of behind the scenes, that means you're probably having a negotiated timeline on when legacy ways of working just won't be possible anymore. So there's essentially an exit plan for how things worked in the old SCE. And I think this last one is definitely the most aggressive, but it's putting in a definite plan for when you'll kind of migrate your workforce and your skilled statistical programmers towards this new world of data science and data science stacks and things like that. So you've got this kind of grand plan to modernize clinical programming. And I think it's important to note that there will be people super excited about this, but there'll also be a lot of people that are skeptical. So for kind of experienced statistical programmers, you've probably seen multiple SCEs roll out. If you've been working for 10 years, it's probably your second or maybe even third SCE that's rolling out now. And there's probably been similar kind of grandiose statements that this new platform is going to make things so much better and efficient and agile and things like that. And maybe there's been some questions if the changes actually did do any of those things. And was it tied to maybe more along the lines of what this Dilbert cartoon is suggesting? But I think the three quotes on the right of this slide are not from individuals, but they're kind of a synthesis of synthesis of the kinds of feedback that we've heard in terms of pushing people to say like, hey, on our new platform, it's Git, it's R, it's container launches. We're kind of dramatically upping the ante in terms of things you need to learn. And there's this kind of core sentiment there of pushback, which is around like statistical programming has been improving for decades. Like there's been an iterative improvement happening, and it's become this really highly specialized and role focused on efficiency. And as part of that, many of the core competencies of what we would consider like good data science have been abstracted away. So there's kind of a conscious decision there to simplify things so that it's completely relevant to the role. And I think a good example there is version control, where, in our last generation of SCEs, we gave a tool for like, pushing things from development to prod or through QC that was very focused to that specific process. If we talk about shifting to Git, you may only be using 1% of what Git is capable of in a normal Git flow for a clinical trial. And we're removing lots of those layers of abstraction between the statistical programmer and the concept of version control, which kind of leads to this questioning of, why would we do this? Why would we spend so long focusing on process and efficiency and then kind of strip away all that abstraction and give people this very agile, but also very complex to learn, because there's so many new languages and tools, platform for working in. So I guess trying to answer that would be a whole new keynote, but thankfully there is a video out there. Sophie introduced this just this morning, but if you go onto YouTube and search for Pharmaverse Ross or Pharma Ross, both searches, at least for me, brought up his video. And so I definitely recommend reading it. So this change, and I think if you want to know the detail of this change, the video has it, is coming. And there is this dramatic shift. So I think kind of giving the cliff notes on why we need to refactor clinical reporting SCEs into more generalized data science SCEs. We have this talent coming out. They're graduating knowing R, sometimes Python, they're knowing Git, and our statisticians are using R. And so why can't statistical programmers use the same language as the statisticians? And why are we kind of having to retrain them on a different way of working than what they've learned in university? So clinical trial design and also the data modalities present continues to grow in complexity. So statistical programmers today are likely to be exposed to things like alterations from an NGS test. So we need to be able to make sure that they know the languages and the tools that would allow them to analyze that. And as Ross's talk goes into, the Pharmaverse has shifted the code base for clinical reporting to now be focused on a collaborative effort in R. So a statistical programmer today is spending more time on software development. They need to be able to handle new data modalities and emerging tools. And there's an expectation there that they would be able to handle these kind of common core data science competencies like Git, environment management, and also be able to keep pace with this, because data science will keep moving. And I think when we're building this current and next generation of SCEs, where we're supporting this shift, where statistical reporting is going from being this separate domain to becoming a specialty within data science. And I think that's a really important thing for us to do, but we have to kind of build a platform that enables that. So we're quite deep into trying to define what it is an SCE today for clinical reporting. And I've spent most of my time talking about what we're doing at Roche. To introduce some of the kind of pan-industry experiences, I can reference some of the discussions we had at the R-Pharma roundtables. So this GIF in the center is a scene from that meeting. But at the roundtables, so Satish and I both chaired the discussions around like what actually are the pain points and what are we tackling at the moment when it comes to SCEs. And I think I've mentioned this in my talk multiple times, but a big one is what actually is an SCE? Like, what are the bounds of an SCE? It's definitely more than generating content from the CSR, but like how much more? And what does that mean to the design of it? And the next two comments on the left are very similar ones, which just is around, we can change things for the statistical programmers, but there's so many other people using these same data sources and these same kind of derived data they're generating, and there's integrations out into many different platforms. So we are having to kind of temper innovation with the ability to maintain other platforms as legacy connections. And I think one topic that popped up a lot was, I guess, stressed within our discussions, was one of the biggest pain points to maintain is that kind of history of file system-based data and so much code tied to that. So, we can shift the way we work, but it also means having to go back and edit a lot of things to handle data being presented to the users in a very different way. When we buy the vendor platforms, so for the last comment on the left, when we buy these vendor platforms, it's actually relatively easy to handle stuff like provenance, like what was the flow of data that produced this plot, because the vendor's done it within their kind of black box kitchen sink platform. If we start breaking this out into more modular pieces, it's actually pretty complicated to do. And we need a lot of kind of coordination between teams. So that's kind of one pain point that we have at the moment. There's always that one, like, okay, well, you want to completely overhaul your SCE. Like, how is this actually going to make us money? And then I think the next two on GXP and exploratory is very related to validation as well. And I'm hoping that's something where a lot of the pain points we've seen in the past can be tempered a bit by really focusing in on just validating a particular process through the platform that is leading to an insight that a decision is made from. And this last point, I guess I hadn't really thought of that much until the roundtables, but it's a super important one, and one we need to think about a lot within Roche now that we're moving into 1.0 for our platform. But it's also what to do with funding. So, if I show this slide, so if we have a vendor product, we pay a license. So in the plot, we have these little dollar symbols, which is representing the cost. And then we have this pink or purple line, which is showing the delightfulness. So this was that phrase used in the Fuse white paper. And over time, we pay however frequent the licenses, we pay that to the vendor, and they iterate on their product. So they have a development team, they're making their product better. So we do see it get better and better over time. If we look at our homegrown solutions, there's often a big initial outlay, but then once we hit 1.0, topics like maintenance or operations start to be discussed, and there's a little bit of a pushback on how would we keep this funded and keep innovating it over time. And I purposely made the curve kind of curve down, because I think one thing we've seen before is when you have a data science platform or any platform in an area which is constantly evolving, when you put it into maintenance and focus, just on fixes and support and things like that, you're not actually maintaining it at the same level, because over time, data science itself doesn't say, hey, Roche just released 1.0 of their SCE. Let's just stop innovation everywhere for 5 years until they do the next SCE. Things keep evolving. New tools come out, and your platform slowly falls behind. And so there's actually, the moment you switch to this mode, decay starts. It starts to become less and less of a great platform over time. So I think a big topic within people moving to the homegrown that was mentioned at the roundtables was this whole, how do we change the way things are funded so that we can make sure that there is this ability to have sustained development once we hit 1.0, and to make sure this platform can keep growing and improving over time. So recapping some of the key questions to tackle with a modern clinical reporting SCE, and its, I guess, wider scope, is what actually is the scope? So I think it should be really important to kind of flag, if you are rolling out an SCE, let's say your last SCE was focused on statistical programmers, what actually is the focus of your next one? Is it still statistical programmers? Is it statistical programmers plus a little bit of what biostats does? Is it all of late stage evidence? Or are you even going broader and starting to kind of connect more with access and going earlier in the pipeline early development? And another really important one is to be clear on what you expect from users. And when I say users, this also is kind of your power users that are helping define workflows on the new platform. So for instance, if you're introducing things like batchless runs, like a statistician's doing trial design in scope, traditionally they might even been using their laptops to do their simulations. Is the way they work and the kind of diverse set of packages they require and potential system libraries and stuff something you want to support as well within your SCE? A really big one, which I think is something that's changing, is how much do we want to abstract away as well? So do we want to put them on a platform that's kind of super process driven and optimized for specific tasks? Or do we want to put them on a more general platform, which then, for instance, Forget might require them to learn 5% of a particular tool, just enough to get by, knowing that occasionally, things will go wrong and suddenly they're having to do some quite advanced things and get things back on track. A really big one is, if we have been validating the entire platform, can we move away from that and start to validate in just the pieces that really do need to get validated. So for instance, what generated the final insight that a decision was made on? And what do we actually need to capture here in terms of provenance metadata? And then I guess what was brought up in the roundtables is also how is that all being handed off and where is it being stored between different products if you are going for quite a modular system. And there's also that discussion on what exactly are we telling users. This is how they worked in the last SCE will compare to what happens in the new SCE. Like, will they be able to work the way they used to work? How long will the way they used to work be supported if it is migrated? And when are we expecting people to adopt the kind of new ways of working that exist within the SCE? Or is that something that, essentially everybody's working the new way because the old SCE will stay in place till you can eventually shut it down? So I've kind of posed a lot more questions than I've answered. And just to mention again that there will be a panel at the close of today where you'll hear from a whole bunch of people involved. And I guess I'm not sure whether to call it the current or the next generation of SCEs, but the ones appearing right now. So there'll be a chance to also hear from a wider group of people. But saying that, I am very open to take some questions, Paulo. And yeah, thank you for your time.
Awesome. Excellent talk. Bravo. Very interesting balancing act of, taking care of what's the legacy and the new things that are to come. We do have time for a couple of questions. I encourage people to put some of these questions in the Slido channel so that they can be answered in the panel later today, because we're not going to be able to go through all the questions. So Eric, maybe if you can give us some of the questions that are flowing in there. So from Jonathan Seed, as long as the CROs are working through SaaS infrastructure, then it is hard to change the internal landscape of managing QCing submissions. Maybe this is more of a comment than a question, but I think there is a question in there, James, in terms of, okay, how then CROs will work with us or with the pharma companies with new SCEs?
Yeah, I guess that's implying that the work is fully outsourced and it's happening on their own infrastructure, which then 100%, I guess it could be a problem. If the CROs are working on your infrastructure, I guess they're like the statistical programmers within your own company. There needs to be some way to help those companies adopt these new tools, and they're aware of different trainings available. And hopefully it is a journey that the companies will need to take as the Pharmaverse grows from company to company.
Very good. A question from Bill Martin. James, interesting graph on the liveliness. Are you incorporating cost of maintenance on these two tracks?
Yeah, so there was no real data, I guess, as you can guess, behind that graph. And I spent a long time trying to debate whether to make the first one for homegrown bigger or smaller than the license cost. But yeah, I definitely agree with you. And I think when I was putting those kind of decreasing things, I was talking about maintenance. So I think it's that general idea, like if you know the L0, L1, L2, L3, so L1 are kind of your people responding to problems like, oh no, I can't use the platform because of some bug. And L3 are kind of implementing features. I'm talking about basically the money disappearing for L3, or at least shrinking dramatically. That's the pain point. But hopefully still keeping enough money in it that the lights stay on. And it can respond to new versions of RStudio, Workbench, and stuff like that.
All right, awesome. Another question from Holger Dash. By moving away from the process-driven platform to self-managed containers, what skills needs to be acquired?
Yeah, I really wish. So we have someone dedicated to this. There's a guy called Kieran Martin at Roche, who's our enablement lead. So there's definitely a lot of skills that need to be required. I think the self-managed containers isn't the hardest piece, because most statistical programmers aren't self-managing the container. They're taking the one we release every 6 months, what we call like a managed container. and it doesn't have the packages in it, so you just have to get the packages from Posit Package Manager. So yeah, they're not stuck on 4-month-old packages. But the main point there is that managed container is hopefully sufficient for like 90% of use cases or 95%. And it's only that last kind of 5% that is saying, well, actually, I'm doing some experiments. I want to have some random system libraries added to my container.
All right. We can wrap up now. I'm sure there are many other questions. Again, I encourage people to put those questions in this Slido so that we can answer them in the panel later today. Thank you so much, James, for this presentation. We are going to go in a short break until 11. So, Eric, back to you.